Welcome to David Alexander Maths Tuition. This is chapter 8e on binomial estimation. Okay, so let's take a look at our first example. Find the first four terms of the binomial expansion in ascending powers of x of 1 take x over 2 to the power of 7. Well, this is something we can definitely do already. The only thing that might be a little bit confusing for you is it says x over 2. You might prefer to write this as 1 minus 1 half x to the power of 7 so that you've got a number in front of the x. So we'll do our usual. That's going to be 1 to the power of 7 plus 7 choose 1 multiplied by 1 to the power of 6 multiplied by, remember this is 1 negative half x. The next term will be 7 choose 2, 1 to the power of 5 negative 1 half x all squared. And the fourth term, which is the final term that we're interested in here, is 7 choose 3, 1 to the power of 4 negative 1 half x all cubed. Now, the good news is 1 to the 7, 1 to the 6, 1 to the 5, 1 to the 4 is always 1. So that we've got 1. So we can just ignore these completely. The 1 to the 6, as I say, it's 1. So it's not going to do anything particularly interesting here. So let's just get rid of that. So 7, choose 1, times minus 0.5. So that is minus 7 over 2. So let's get rid of that plus sign. Minus 7 over 2x. The next term is 7, choose 2. Again, forgetting the 1 to the power of 6 times minus 0.5 squared, which is the same as positive 0.5 squared. And we are getting, let me just double check that, 7 choose 2 times 0.5 squared. So we're getting, 21 over 4. So that's plus 21 over 4x squared. And the final term we're interested in, 7 choose 3 times 0.5 cubed. I'll just remember to make that negative because it's there's 3 minus 1 half x is there. So that's minus 35 over 8x cubed. Okay, the expansion continues, but as far as we're concerned, this is all we are interested in. Okay, done. By substituting an appropriate value for x, okay, what's that all about? Find an approximate value for 0.95 to the power of 7. Okay, well, this is to the power of 7. And this is to the power of 7 as well. So what we can say is, well, what is x then? Well, if we're going to set 1 minus 1 half x equal to that 0.95, and now from this we can work out what x is. So we're going to subtract 1 from both sides. So that negative a half x is minus 0.05. So therefore, positive half x is positive 0.05, so x is double that, x is 0.1. So what this means is if I substitute x with 0.1, 1 minus 0.1 over 2 is 0.95. So these two things are exactly the same. Now, since we know that 1 minus a half x to the power of 7 is the same as 1 minus 7 over 2x plus 21 over 4x squared, blah, 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 that means that if I substitute 0.1 into this equation, then I'm going to get an approximate value for 0.95 to the power of 7. So what I'm going to type in is 1 minus 7 over 2 times by 1/10 or 0.1 plus 21 over 4, 1 over 10 squared. I don't know why I put 1/10. Actually, I'm more likely to type it in as 0.1 on my calculator. It's a lot easier. Minus 35 over 8. 1/10 cubed. Okay, so in theory, in reality, what I'm going to do is I'm just going to type in 0.1 into my calculator, press equals, and then just recall that using the ANS button. So 1 minus 7 answer divided by 2 plus 21 answer squared divided by 4. Take away 35 answer cubed. Oops, something's gone wrong on my calculator there. So 34 answer cubed divided by 8. Okay, and what do I get? I get 1117 over 1600. Well, let's get that as a decimal. So that is 0.698125. Right, okay, there we go, we're done. But we can check our answer. What actually is 0.95 to the power of 7? If you've got this right, then 0.95 to the power of 7 should be pretty close to this well, our estimation. Well, when we type 0.95 to the power of 7 into our calculator, we'll get the exact answer. This is just a slight approximation, and when I type this into my calculator, I get 0.698337 continues. So to 3 decimal places, it's identical. So there we go. Well, that makes us feel happy that we've definitely got it right, because we've got an answer that is actually close to the real thing there. Okay, so let's take a look at our second example. So if x is so small that terms of x to the power of 4 and higher can be ignored, show that this stuff on the left is the same as this stuff on the right. So what we're going to do is we're going to ignore the 3 minus x for now. Let's just focus on the 2 plus x to the power of 5. So 2 plus x to the power of 5 is 2 to the power of 5 plus 5 choose 1, 2 to the power of 4x plus 5 choose 2, 2 cubed x squared plus 5 choose 3, 2 squared x cubed. Okay, so first of all, what is 2 to the power of 5? Is it 32? Yes, 32. So we're going to get 32 plus 5 times 2 to the power of 4. Hopefully by now you know that something choose 1 is always that something. So 5 choose 1 is 5, 6 choose 1 is 6, etc. But if not, just type it into your calculator. It's better to be safe than sorry. So 32 plus 80x plus 5 choose 2 times 2 cubed, which is 80 again. So that's going to be 80x squared, and 5 choose 3 times 2 times 2 is plus 40x cubed. Okay, so I've done the binomial expansion on the 2 plus x to the power of 5. Well, I haven't done all of it actually, have I? But the reason why is because I'm only going as far as the x cubed terms. So now all I need to do is, so dot dot dot, this continues. So I'm going to multiply this by 3 minus x. Now remember that I'm only interested in x, everything up to x cubed. So first of all, it's safe to multiply everything through by 3. 3 times 32 is 96. 80x times 3 is 240x. 240x squared plus 120x cubed. Now I'm going to multiply through by negative x. Negative x times 32 is minus 32x. Negative x times 80x, that is minus 80x cubed. And negative x times positive 80x squared is minus 80x cubed. There we go. Oops. I don't need to multiply the negative x by the 40x cubed, because that will give me an x to the power of 4 term, and we're ignoring that. Okay, so we've got our 96. Let's look at the number of x's. We've got 240x and negative 32x, which guess what is plus 208x. We have 240x squared, take away 80x squared, so that's plus 160x squared as required, and 120x cubed minus 80x cubed, which is plus 40x cubed. There we go. So we have shown that the stuff on the left hand side is approximately the same as the stuff on the right hand side there. Okay, so here's our third and final example. Write down the first 4 terms of the expansion. So again, you might want to turn that into 1 minus 1/5 x to the power of 8. So the first term is 1 to the 8 plus 8 choose 1, 1 to the power of 7 minus 1/5 x. That's the second term, plus 8 choose 2, 1 to the power of 6 minus 1/5 x all squared, plus 8 choose 3, 1 to the power of, that's a sixth, 1 to the power of 5 minus 1/2 x cubed. So the first term is 1. Again, the 1 to the 7 we can now ignore. 1 to the 6, 1 to the 5, all not doing anything particularly significant. 8 choose 1 is 8, so that is going to be minus 8 over 5x. 8 choose 2 times, 1 over 25. So this is going to be positive because it's a negative thing squared. So that's going to be plus 28 over 25x squared. And the final term that we're interested in, 8 choose 3 multiplied by, so it looks like a half, that should be a fifth. So I'm going to type in times 0.2 cubed and then just make the answer negative. And so that is negative 56 over 125x cubed. There we go. So there we have the first 4 terms of the expansion. Okay, so we've got this to the power of 8 and this to the power of 8. So what we need to do is to make the 1 minus 1/5 x equal to 0.954. So minus 1/5 x is going to be 0.954 take away 1, which is minus 23 over 500. So positive 1/5 x is positive 23 over 100. So therefore x equals 0.23. Okay, let me just double check that. It seems like normally you get nice values like 0.1 or 0.05. So 1 take away 0.23 divided by 5. As long as this equals 0.954, we are good. And it does, so there we go. Okay, so I need to find an approximate value of 0.954 to the power of 8. So let me just check what 0.954 to the power of 8 is. It should be, my calculator is saying 0.6860993338. That's the exact value. So we want the approximate value. So what we are doing is we're substituting the 0.23 into our expansion here. So 0.23, going to hit equal so I can recall it using my answer button. 1 minus 8 answer divided by 5 plus 28 answer squared divided by 25, subtract 56 answer cubed divided by 125, and I'm getting 0.6857971884. Okay, there we go. So they're pretty close. I mean, well, they're the same to 3 decimal places, so they're pretty close. So this is the approximate value. Now on to the final part. We want to calculate the percentage error. Okay, so the error is the difference between these two. So it's going to be the difference divided by what it actually should be multiplied by 100. So the difference is, well, which one's bigger? The top one is bigger, so it's going to be this number here. Subtract this one divided by the top one. Okay, so 0.6860993338 minus the answer that was, because this lower one was currently sitting on my calculator, equals whatever. Divide that by the the actual one again, so 0.6860993338 multiplied by 100, and we'll probably find this percentage error is really, really small. Yes, it is. So the percentage error is 0.04404. Give it to 5 decimal places. I mean, they've not asked, but there we do. There we go. So we can see the percentage error is really, really small. So even by only taking the first 4 terms of the expansion and ignoring everything else, we're still getting pretty close to the actual value of 0.954 to the power of 8. There we go.